day everyone. This is my prelim lab exam, my report about Lamport's mutual exclusion algorithm. So, Lamport's algorithm for mutual exclusion in distribution system. Lamport's distributed mutual exclusion algorithm is a permission-based algorithm proposed by Lamport as an illustration of his synchronization scheme for distributed systems. Information-based timestamps is used to order critical section requests and to resolve any conflict between requests. In Lamport's algorithm, critical section requests are executed in the increasing order of the timestamps. For example, a request with a smaller timestamp will be given permission to execute critical section first than a request with longer timestamp. So algorithm explained. In this algorithm, three types of messages, request, reply, and release, are used and communication channels are assumed to follow FIFO order. Next, a site send a request message to all other sites to get their permission to enter critical section. A site send a reply message to requesting site to give its permission to enter the critical section. And last, a site send a release message to all other sites upon exiting the critical section. Every site SI keeps a QE stored critical section request order by their timestamp. Request QE denotes the QE of site SI. A timestamp is given to each critical section request using Lamport's logical clock. Timestamp is used to determine priority of critical section requests. Smaller timestamp gets a priority over larger timestamp. Execution of critical section requests is always in the order of their timestamp. So this is the algorithm to enter the critical section. First, when a site SI wants to enter the critical section, it sends a request message request to all other sites and places the request on request QE. Here, TSI denotes the timestamp of the site SI. And second, when a site SJ receives the request message of request from site SI, it returns a timestamp reply message to site SI and places the request of site SI in request QE. Second, to execute the critical section, a site SI can enter the critical section if it has received the message with timestamp larger than from all the other sites and its all request is at the top of request QE. To release the critical section, when the site SI exits the critical section, it removes its own request from the top of its request QE and sends the timestamp release message to all other sites when site SJ receives the timestamp release message from SI. It removes the request of SI from its request QE. Message complexity. Lamport algorithms requires invocation of 3 over n-1 messages per critical section execution. This 3 n-1 message involves first, n-1 means message request message, and n1 reply message, same with release messages. Drawbacks of algorithm. First, unreliable approach. Failure of any one of the process will halt the progress of entire system. And last, high message complexity. Algorithm requires 3n-1 message per critical section invocation. Its performance. First, synchronization delay is equal to maximum message from transmission time. Second, it requires 3n-1 message per CS execution. And last, algorithm can be optimized to 2n-1 message by omitting the reply message in some situations. So that's all, and thank you for your listening.